Okay, so real quickly, experimental probability. This is section 1.1 and 1.3. 1.1 introduces it, and 1.3 compares it to theoretical probability. So last day we looked at theoretical probability, and that's what should happen, and what actually happens is experimental probability. Oops, let me do that. And again, what you're going to look for here is very similar, NA over NS. So what you're looking for here is the number of ways you find success over the total number of trials. So that's really the way you do that, success over trials. So what happens is this: you define success as being something, and let's say, so let me skip this sort of thing here, but let's say we had a spinner and it had red, blue, and yellow, and this happened 6 times, 2 times, and 4 times. Okay, so we spun this 12 times, and these are the results. The experimental probability is not what should happen. What should happen is that 1/3 of the time you should get red, 1/3 of the time you should get blue, and 1/3 of the time you should get yellow. But what did happen was, here, if I was looking at the probability of red, 6 out of 12 times I got red, which is 0.50. That's what happened. That's experimental probability. Okay, tiny interruption there. Okay, so I forgot what I was saying. So the experimental probability is what actually happened. So you write that like that. It's just what you observed over the total number of times. And so, for example, the probability of B happening is 2 over 12. And then what you will notice is this, with this, is if you add up all the probabilities, 2 over 12, 6 over 12, and 4 over 12, you will find out that they add up to 1. Now, if as decimals, if that doesn't work exactly, that's not a big deal, right? If I'm rounding, like in this case, I believe it's 0.17 plus 0.5 plus, what's 0.33, I think? It would be 1/3. So in this case, it would add up. But you might notice that because of rounding, you might add up to 0.99. Anyway, so that's experimental probability. And why does that matter is it has to do with theoretical probability. Subjective probability, if you ever see that term, that's people who misuse, basically using their guts in probabilities. It's really just junk, to tell you the truth. But if you say something like, I'm 99% sure that this is going to happen, or 50-50 chance of that happening, that's not based on science or experiments. It's based on intuition, and we call that subjective probability. So in general, what happens is experimental probability turns into kind of a likelihood. It never is theoretical probability, but we do use experimental probability and theoretical probability together. So for example, what you'll do is you'll come up with weather patterns, any sort of forecast, economic forecast, weather forecast, that sort of thing. They're based off experimental probability. So as you roll dice, keep track of the results, what you'll see is, what happens is, in the long run, what happens is this right here. As you keep running the experiment, the number over time, what's going to happen is the experimental probability will approach theoretical probability. So let me just do this with flipping a head and a tail. If I flip a coin and I get a head, and then I get another head, and then another head, and then I get a tail, and I look at this and I say the experimental probability of getting a head is 3 out of 4. That's true, and that's way higher than what it should be, at 0.5. But if you keep flipping and keep track of this and keep going, over time this will get lower and lower until it gets close to 0.5. It may go up and down, but eventually it will approach and get to the theoretical probability. So very simple lesson. Hope that went well. Take care.